For most of human history, figuring out if a suspect was lying came down to a staring contest. Detectives and judges relied entirely on their gut feeling to read a person's face and decide if they were telling the truth. There was simply no objective metric. If you sweat under pressure or stumbled over your words, your fate rested on whether the interrogator interpreted that as guilt or just nerves. In 1904, a Czech psychology student named Max Wertheimer started looking at this problem differently. He hypothesized that deception requires active physical effort. To tell a lie, your body has to work harder than it does to tell the truth, creating physiological changes that are entirely out of your control. Based on this idea, Wertheimer built an academic prototype, a machine he called a lie detector, designed to capture that bodily effort. The question was whether an instrument could be sensitive enough to bypass human intuition and record a purely biological response to guilt. Wertheimer's theory moved the search for truth out of the hands of philosophers and placed it squarely onto the workbench of biologists. By 1921, that academic theory made its way into active law enforcement in California. John Larson, a medical student working with local police, realized that early prototypes could be adapted to interrogate actual criminal suspects. He collaborated with officers to build a more complex, multivariable machine known as the polygraph. The operating premise was straightforward. When a suspect is afraid of being caught in a lie, their nervous system triggers an involuntary fight or flight response. To capture this, Larson's polygraph monitored 3 distinct physiological metrics simultaneously: blood pressure, pulse, and the rate of breathing. As the subject sat through questioning, the machine translated those invisible internal fluctuations into physical, continuous data streams. The erratic red lines represent the suspect's biological rhythms, drawn directly onto a scrolling reel of chart paper. Investigators watched the pens move in real time, marking the paper with blue ink to note exactly when a question was asked and where sharp physiological reactions occurred. Larson took the abstract concept of deception and turned it into hard, measurable evidence that detectives could review and hold in their hands. Over the following decades, police departments across the country adopted the polygraph, moving it into standardized clinical interrogation rooms. But as the tests became commonplace, researchers identified a massive flaw in how the machine was being used. The polygraph does not actually detect lies, it strictly measures stress. This graphic illustrates the core problem. The human body reacts the exact same way to the fear of being caught in a lie as it does to the intense, honest anxiety of simply being strapped into an interrogation machine. Because those biological responses look identical on paper, investigators end up with a high rate of false positives, accidentally accusing truthful people of lying. This biological ambiguity eventually caught up with the machine in the legal system. Today, many courts refuse to accept lie detector tests as evidence during a trial because the results are too unreliable to sway a jury. Wertheimer and Larson succeeded in measuring human biology, but their invention could not meet the rigorous threshold of absolute legal proof. Our physiology is so sensitive to pressure that it creates a paradox. The very tool designed to catch a liar can easily incriminate an honest person, while letting a calm, practiced liar slip right through.